The Egyptian pyramids stand tall, like silent giants in the desert of time. These structures are not just piles of stone, but symbols of a once great civilization. These massive structures have captured our imaginations for centuries. They are architectural marvels that modern man still admires and learns from. Their immense size and intricate design speak to the ingenuity of a civilization that thrived thousands of years ago. Each stone, each angle holds its own mysteries and stories. Tourists from all over the world come to Egypt each year, drawn by the captivating beauty of these ancient wonders. They come to admire, to experience, and to learn about a piece of human history. But the pyramids are more than just tourist attractions. They are cultural treasures, holding the secrets and knowledge of the ancient Egyptians. They are time capsules, giving us a glimpse into the sophisticated minds of those who built them. Each stone, each inscription carries messages from the past. As we gaze upon these majestic structures, a natural question arises. How did the ancient Egyptians achieve such a feat of engineering? This question has puzzled generations of researchers. The Great Pyramid of Giza, the most impressive of them all, is made up of over 2 million stone blocks. Each block was cut and transported with incredible precision. Each block weighs an average of 2.5 tons, with some weighing as much as 15 tons. Moving and assembling these giant stones was an incredible feat. The scale of the project is mind-boggling, even by modern standards. It's hard to imagine how the ancient Egyptians accomplished this without the help of modern technology. Building the pyramids was a massive undertaking, requiring not only immense physical labor but also a sophisticated understanding of mathematics, engineering, and astronomy. This knowledge was passed down through generations. The precision in the pyramid's construction is astonishing, with the sides aligned almost perfectly with the cardinal directions. This shows a deep understanding of astronomical principles and mastery of surveying techniques. This level of accuracy points to a deep understanding of astronomical principles and a mastery of surveying techniques. The ancient Egyptians used advanced tools and methods to achieve this. The pyramids weren't built overnight. They were the result of generations of knowledge passed down through centuries. Each stone, each inscription carries messages from the past. They were the result of generations of knowledge passed down through centuries. The ancient Egyptians left behind very few detailed written records of their construction methods. The ancient Egyptians left behind very few detailed written records of their construction methods. This has led to much debate and speculation among scholars about how these incredible structures were built. This has led to much debate and speculation among scholars about how these incredible structures were built. Each theory offers a new perspective, but the mystery of the pyramids remains, waiting to be unlocked. Building the pyramids presented the ancient Egyptians with a logistical challenge of unprecedented scale. The first hurdle was transporting millions of stone blocks from the quarries to the construction site. This was no easy feat, considering the sheer weight of the stones and the distances involved. The most widely accepted theory is that the Egyptians used giant wooden sledges to move the stones. These sledges could be lubricated with water or mud to reduce friction. Evidence suggests that large teams of workers would pull these sledges, using ropes and possibly rollers, over long distances. The Nile River played a crucial role in this process. The Egyptians would transport the stones during the annual flood season using the river's current to navigate the heavy stone. Upon reaching the Giza Plateau, the stones were then moved to the construction site using a system of ramps and levers. The exact design of these ramps is still debated, but it's clear they were essential for moving the stones vertically. Some theories propose straight ramps, while others suggest spiral ramps built around the pyramid as it grew. Whatever the method, constructing these ramps was a significant engineering feat in itself. Transporting the stones was just the first step in a long and arduous process. Once at the construction site, the stones had to be lifted, maneuvered into position, and assembled with incredible precision. With the massive stones at the base of the pyramid, the next challenge was lifting them into place. This required a deep understanding of mechanics and engineering. This is where the ingenuity of the ancient Egyptians truly shone. They developed various methods to tackle this problem. This is where the ingenuity of the ancient Egyptians truly shined. They developed a variety of methods to tackle this problem. While there's no definitive proof of a single method, archaeologists and researchers have put forward several theories. Several compelling theories have been proposed. These theories are based not only on physical evidence but also on historical and cultural records. One popular theory involves the use of giant earth ramps. These ramps would have been constructed from earth and rubble. These ramps would be built around the pyramid, forming a complex and efficient system, gradually increasing in height as the structure grew. This allowed workers to easily move the stone blocks to higher levels. Workers would then pull the stones up these ramps using ropes, rollers, and levers. This was a process that required the coordinated strength of many people. This method, while labor-intensive, was achievable with the technology available at the time. It demonstrates the ingenuity and resourcefulness of the ancient Egyptians. Another theory proposes the use of a lever and counterweight system. This system may have been developed from irrigation tools. This method, known as the shaduf, was used by the Egyptians for irrigation purposes. It demonstrates their ingenuity and adaptability. It involved a long lever balanced on a pivot, allowing for easier lifting of heavy objects with a bucket on one end and a counterweight on the other. This helped to offset the weight and make lifting the stones more manageable. A similar system on a much larger scale could have been adapted to lift the massive stones of the pyramids. This speaks to the creativity and resourcefulness of the ancient Egyptians. A more recent theory suggests the use of internal ramps within the pyramid itself. This theory provides a fresh perspective on how the pyramids were built. This theory proposes that ramps were built inside the structure of the pyramid, protecting them from the elements, allowing stones to be transported to higher levels. This could have reduced the effort and time required to complete the structure. These internal ramps would be removed after the pyramid's completion, leaving no visible trace. This explains why we haven't found clear evidence of them, leaving no visible trace. This makes this theory difficult to prove. Each of these theories has its supporters and detractors. Debates about pyramid construction methods are ongoing. The lack of conclusive archaeological evidence makes it difficult to prove any single method. This adds to the complexity of the research. It is possible that the ancient Egyptians used a combination of techniques demonstrating their flexibility and adaptability, adapting their methods to suit the specific challenges of each stage of construction. This speaks to the ingenuity and resourcefulness of the ancient Egyptians in constructing these magnificent structures. The construction of the pyramids wasn't just a feat of manual labor. It was also a testament to the ancient Egyptians' advanced understanding of mathematics. These massive structures required not only muscle power, but also precision and a deep knowledge of mathematical principles. The pyramids are not just piles of rock. They are precisely calculated structures embodying complex geometric principles. Each stone is placed with remarkable accuracy, reflecting the Egyptians' profound understanding of geometry and mathematics. The Great Pyramid, for example, exhibits a remarkable degree of mathematical precision. With an original height of approximately 481 feet, it was one of the tallest structures in the world for thousands of years. Its sides are almost perfectly aligned with the cardinal directions, with an error of less than 0.05 degrees. This suggests that the Egyptians used advanced surveying techniques and possessed a deep understanding of astronomy. This level of accuracy required sophisticated surveying techniques and a deep understanding of astronomy. The Egyptians observed the stars and used them for orientation and measurement, ensuring that the pyramids were built with the utmost precision. The Egyptians' use of the royal cubit as a unit of measurement is further evidence of their mathematical prowess. The royal cubit wasn't just a unit of measurement, but a vital tool in ensuring consistency and accuracy in construction. The royal cubit, based on the length of the pharaoh's forearm, was standardized throughout Egypt, ensuring consistency in building projects. This allowed for structures to be built with great accuracy and uniformity. The dimensions of the Great Pyramid also reveal intriguing mathematical relationships. Researchers have discovered that the pyramid's proportions and dimensions are not random but carefully calculated. For example, the ratio of the pyramid's height to its base is close to the golden ratio, a mathematical ratio found throughout nature and considered aesthetically pleasing. The golden ratio appears in many aspects of nature, from seashells to flowers and even the human body. Whether this was intentional or coincidental is still a subject of debate among scholars. Some believe the Egyptians deliberately incorporated the golden ratio to create harmony and balance in their designs. The Egyptians' understanding of geometry is evident in their ability to calculate the volume of pyramids and other complex shapes. They used mathematical formulas to ensure that each stone was placed in its precise location. These calculations were essential for estimating the amount of stone required and the overall scale of the project. This allowed them to plan and execute massive construction projects with great accuracy and efficiency. The pyramids stand as a tangible testament to the mathematical prowess of the Egyptians, demonstrating their ability to apply abstract concepts to real-world engineering challenges. These structures are not just symbols of power and religion, but also testaments to human ingenuity and innovation.